factorization of a quadratic polynomial. So here we are going to discuss about the quadratic polynomial factorization, or the factorization of a quadratic polynomial, in which quadratic polynomial, or in other words called as the quadratic expression. So here quadratic expression is nothing but a second degree expression of single variable, that is ax square plus bx plus c is the general form of the quadratic expression or a quadratic polynomial. So here we are going to factorize such a sort of quadratic expressions which are in the form of x square plus bx plus c, in which a is the coefficient of x square, whereas x is the variable in it, whereas b is the coefficient of x and c is a constant, is a real constant. So here first of all let us discuss about the quadratic polynomial, or in other words a quadratic expression. So in this regard, an expression, or in other words a quadratic expression in the form of ax square plus bx plus c, in which a is not equals to 0, whereas b and c are real numbers or real constants. So here an expression, or in other words a quadratic expression, which is in the form of ax square plus bx plus c, whereas a, which is the coefficient of x square, so here a is the coefficient of x square, b is the coefficient of x and c is the real constant, whereas a is not equals to 0 and b comma c are belonging to real numbers. Which are the real numbers is known as a quadratic polynomial, or a quadratic expression. So whereas here the gen form, so here the general form or the gen form of a quadratic, quad indicates the quadratic polynomial, is ax square plus bx plus c, whereas in which a is the coefficient of x square. So here coefficient of x square in ax square plus bx plus c is equals to a. Similarly, say coefficient of x is equals to b, whereas so here real constant or a real number, so here real constant is nothing but the c. Now we are going to factorize few quadratic polynomials. Say here for that sake we are going to perform one example number 1. So here factorize quadratic polynomial, that is x square plus 7x plus 12 Solution starts now. Whereas in the solution, as per the problem, so here as per the problem, the quadratic polynomial which is given for us is of quadratic polynomial given is x square plus 7x plus 12. So we have to factorize the polynomial, that is quadratic polynomial x square plus 7x plus 12. So here x square plus 7x plus 12 is given for us. So here, so we can split this 12 as the factors of this 12 are, so 6 into 2 is also 12 and 4 into 3 is also 12 and 12 once is also 12. So these are the factors of 12. Whereas the middle term is of 7x, so variable x coefficient is of 7. So here these are the factors, first two factors in the first assumption, in the first option is of 6 into 2 is of 12, the second option is of 4 into 3, 4 3s is of 12, the third option is of 12 into 1 is of 12. But in the first case, so in the first option, so we are going to check either by adding these two factors or by subtracting these two factors, we must get the middle term. So by adding these two factors, that is 6 plus 2 is of 8, 8 is not the variable, 8 is not the coefficient of x. Similarly, by subtracting 6 minus 2 is of 4, so here 4 is not the coefficient of this x, 7 is the coefficient of x. So here, so whatever we are choosing as a 6 and 2 is the wrong option. Then let us go for 12 and 1. 12 plus 1 is of 13, which is not the coefficient of this x. 12 minus 1 is of 11, 11 is not the coefficient of x. Either by adding the factors or by subtracting the, we must get the middle term. So here this is also not the option, correct option. Then now let us go for 4 and 3. Let us subtract first of all. 4 minus 3, 4 minus 3 is of 1, 1 is not the correct coefficient of this x. So here let us add up. 4 plus 3 is of 7, so here this is of 7, 7x. So here, so instead, so we can choose the 4 and 3 as the factors. So here that implies x square plus this 7x can be split as 4 and 3 as 4x plus 3x. So here by adding these two factors, that is attaching x, that is 4x plus 3x equals to 7x, and 12 must be written as it is. Then now let us remove the brackets. So that implies x square plus 4x plus 3x, because there is a positive sign in front of this bracket, there won't be any changes in the signs inside the bracket. Then now plus 12. Here in first two terms and the last two terms I want to take the common. So here that implies in the first two terms I want to take x as common. Out of 2 x's, x square can be split as x into x. So out of 2 x's here, 1 x is taken as common, 1 more x will be written inside the bracket, plus x is already taken out. Between 4 and x there is of into symbol. When x is taken out as common, then only 4 is left over within the bracket, plus the factors of 12 are of 4 and 3. So here when 3 is taken out, so here 12 can be written as 4 into 3. So 1 3 can be taken out from the factors of 12. So here when 3 is taken out as common out of this 3x, so here 3 is taken out as common, just x is left over within the bracket, plus 3 number of times, that is 4 times, 3 fourths is of 12. Then now, so here among these two factors, so among the first term, that is x into x plus 4, and the second term, that is 3 into x plus 4, so here x plus 4 is common. Then now let us take x plus 4 as common. That implies when x plus 4 is taken out as common, then now within the bracket, when x plus 4 is taken out as common, then now in the first term when x plus 4 is taken out as common, x is left over, and whereas in the second term when x plus 4 is taken out as common, so 3 is left over, that is x plus 3 is left over as the second factor. So here x plus 3, then now that implies, so here x plus 4 into x plus 3 are the factors of the given, that is x square plus 7x plus 12. So here therefore hence x square plus 7x plus 12 is factorized as x plus 4 and as well as x plus 3. So, in this manner, so we have factorized x square plus 7x plus 12 as the factors, as x plus 4 is the first factor and x plus 3 is the second factor of the given quadratic polynomial.